Good afternoon, and welcome to Hand-Wavy Chemistry, where we do not delight in the details, but rather bask in the big picture. Today, it's problem time, where we answer chemistry questions. In our last problem time session, we looked at how to convert between moles and mass using the molar mass. Today, we're going to look at how to calculate the concentration of a solution in terms of moles per liter. This is a very important type of calculation because most chemical reactions are carried out in solution. So let's get started. For our first question, we are asked what is the concentration of a solution of sodium chloride when 0.140 moles are dissolved in enough water to give a total volume of 125 milliliters. Concentration in chemistry is represented in moles per liter. So in order to calculate the concentration, we need to take the number of moles and divide it by the volume in liters. So in this case, we've been told that the number of moles is 0.140, but we've been given the volume in milliliters. So first, we need to convert that into liters. There is 1,000 milliliters in a liter, so 125 milliliters is the same as 0.125 liters. When we perform this calculation, we get an answer of 1.12 moles per liter. There are some different ways to write the units for this. For example, it could also be written as 1.12 moles per liter, like so, or sometimes it's written as 1.12, and then a capital M is used as a shorthand for moles per liter. Finally, a short way to write concentration is to use a square bracket. So square bracket NaCl like this means the concentration of sodium chloride. For our second question, rather than being given the number of moles being dissolved, we have instead been told the mass of material. We've been told that there is 1.89 grams of calcium hydroxide, and it has been dissolved in enough water to give a final volume of 1.20 liters. So the first thing we need to do is convert from grams into moles. To do this, we need to know the molar mass. We find this out by looking at the periodic table and adding together the molar mass of calcium with 2 times the molar mass of oxygen and 2 times the molar mass of hydrogen. Doing so, we find that the molar mass of calcium hydroxide is equal to 74.093 grams per mole. So the number of moles is going to be equal to the mass over the molar mass. So 1.89 grams divided by 74.093 grams per mole, which equals 0.02551 moles. Now we know how many moles of material we have, we can find the concentration, because the concentration is equal to the moles divided by the volume, so 0.02551 moles divided by 1.20 liters gives a final concentration of 0.0213 moles per liter. So let's do one last practice question where we are dissolving a solid to find a concentration. In this case, we're going to deal with some larger quantities of material. The species being dissolved is copper 2 sulfate pentahydrate, and we've been told that it has a molar mass of 249.685 grams per mole. And 1.22 kilograms are going to be dissolved in enough water to give a final volume of 1.6 liters. The trick here is noticing that the mass we have been given is in kilograms, but molar mass is in grams per mole. So we are going to need to convert 1.22 kilograms into grams. Remember that there are 1,000 grams in a kilogram, Therefore, 1.22 kilograms is equal to 1,220 grams. From this conversion, we can determine that the number of moles will be 1,220 grams divided by 249.685 grams per mole, which equals 4.886 moles. Now we find the concentration by taking the number of moles and dividing by the volume. So 4.886 moles divided by 1.60 liters gives a final concentration of 3.05 moles per liter. The next type of concentration questions I would like to address involve dilution, where we have a solution already and we then dilute it to a different concentration. For these types of questions, the formula that you want to keep in mind is that the initial concentration times the initial volume is equal to the final concentration times the final volume. In this question, we're trying to find a final concentration, so we can rearrange the equation to say that the final concentration will be equal to the initial concentration multiplied by the initial volume divided by the final volume. Interestingly, we don't actually have to convert the units for our volumes into liters. As long as the initial volume and the final volume have the same units, they will cancel out. So we could leave them as milliliters in this case, and it won't affect our final answer. So putting in our values, 0.125 moles per liter multiplied by 225 milliliters divided by 720 milliliters. Remember that this milliliters and this milliliters will cancel out, so it doesn't matter that they're not in liters, gives a final answer of 0.0391 moles per liter. We can also do a bit of a self-check here. Going from 225 milliliters to 720 milliliters, it's roughly 3 times the volume. And 0.125 and 0.0391, it's roughly a 3-fold decrease. So this answer looks sensible. This next type of question is very commonly encountered by somebody who works with concentrated stock solutions that they then dilute down for their application. So we're told that a researcher needs to dilute 75 milliliters of a 1.10 molar solution of sodium hydroxide to a final concentration of 0.250 moles per liter. So the question is, what is the volume that the final solution should be diluted to? We're going to use the same formula as before, that the initial concentration times the initial volume equals the final concentration times the final volume. But this time, we'll rearrange it so that we'll find the final volume, which is equal to the initial concentration times the initial volume divided by the final concentration. Using the values that have been given to us, we have a 1.10 molar solution with a volume of 75.0 milliliters. And the final concentration is 0.250 moles per liter. When we perform this calculation, we find that the final volume should be 330 milliliters. Notice that once again, I didn't have to convert from milliliters to liters because the moles per liter and the moles per liter cancel out. Now our final example is the type of calculation that is done in an analytical lab all the time. They will regularly need to either dilute or concentrate samples, analyze them, and then determine what the initial concentration was. So in this example, we're told that a 1.0 milliliter aqueous sample, which means that it's in water, is diluted to 25 milliliters for analysis. The concentration of the diluted sample is 0.036 moles per liter. So what was the concentration of the initial sample? Once again, initial concentration multiplied by initial volume equals that final concentration multiplied by the final volume. We want to determine the initial concentration, so we will rearrange it so that the initial concentration is equal to the final concentration times the final volume divided by the initial volume. We can now put in the values provided. Final concentration, 0.036 moles per liter. Final volume, 25 milliliters. Initial volume, 1.0 milliliters. So the initial concentration must have been 0.90 moles per liter. There is one other way we might choose to represent the amount of a chemical, and that would be its molar volume, expressed in something like liters per mole or cubic meters per mole. But that is a story for another time. I hope you have enjoyed this video, and if you have, please make sure to like, subscribe, and share it with your friends. And if there is a question you'd like to see answered in a future problem time, please put it in the comment section down below. Thank you, and I hope you have a wonderful rest of your day.